The question is, the base of an equilateral triangle with side 2a lies along y-axis such that the midpoint of the base is at origin. Find the vertices of the triangle. Okay, now to solve the question, first of all I draw coordinate axis. Okay, so this is my coordinate axis, and on this coordinate axis I'm going to now draw an equilateral triangle. Okay, so equilateral triangle is such that the base of the equilateral triangle with side 2a lies on y-axis. So I draw this, that is the base of an equilateral triangle. Okay, and I'm going to complete an equilateral triangle like this. Okay, so because one side of an equilateral triangle lies on the y-axis and the midpoint is origin and the length of the side is equal to 2a, so this will be a on this side and the length of the side will be a on this side. Okay, so the coordinate of this point will be 0 comma a. Okay, because this point lies on y-axis, and similarly this point will be equal to 0 comma minus a. And I have taken the other vertices on x-axis because one of the base lies on y-axis, okay, and the perpendicular bisector of the base is x-axis. Okay, being symmetric figure, the other vertex is also going to lie on x-axis. So the coordinate of this point is unknown to me. Okay, so I assume that the coordinate of this point is x comma 0 because it lies on x-axis. Now a very important conceptual point is this, that it is given that the base of an equilateral triangle lies on y-axis, right? But it is not given that the vertex is going to lie on the positive x-axis or negative x-axis. So I have two possibilities here, that the other vertex, suppose if this point is A, this point is B, and this point is C, then there is another possibility that the third vertex, which is B, can lie this side also, that is on the negative x-axis. Okay, right? So I can assume that this point is as equal to B dash, and there is another possibility to complete an equilateral triangle like this. Okay, so there are two equilateral triangles possible. Okay, so in this condition what we have to do, we have to find the vertices of an equilateral triangle. Okay, so okay, now two vertices A and C are known to us. Okay, we have to just calculate the third vertex. Okay, and last of all, the length of each of the side of the equilateral triangle will be 2a, because it is an equilateral triangle. Each side will be of length 2a. Okay, because AB, that is the side of an equilateral triangle, is equal to 2a. Okay, therefore applying distance formula between the point A and B, we are going to get the same value again. So I can write this under root of applying the distance formula for these 2 points, that is A and B. I'm going to get 0 minus x whole square plus A minus 0 whole square is equal to 2a, or on squaring both sides I'm going to get this as here square root are going to cancel, here this will become whole square, that is equal to 4a square. On opening the terms of the bracket, I'm going to get this as x square plus a square, or x square is equal to 4a square minus a square, that is 3a square, or x is equal to plus minus root 3a. Okay, so what I get here is this, that x is equal to plus minus root 3a. So this suggests that there are two triangles possible. So the coordinates of this point B will be equal to root 3a comma 0, and this point will be equal to minus root 3a comma 0, because B dash lies on negative x-axis and B lies on positive y-axis. Therefore, vertices of triangle R. So there are two options. First, I can write this as 0a, 0 minus a, and root 3a comma 0. Okay, and the second condition is this: 0a, 0 minus a, and minus root 3a comma 0. So this is my required answer.